Okay, so here's John Conway's version of it, of the Collatz conjecture. And this one seems like it's exactly the same idea, but it's different for a couple of pretty interesting reasons. So we just take any number, n, any positive integer again. If it's 2x, we're going to map it to 3x. If it's 4x plus 1, so 1 more than a multiple of 4.
Yeah.
Go to 3x plus 1.
So 1 more than the multiple of 3.
Right, so we'll talk about how to achieve this in a minute. And if it's 1 less than a multiple of 4, multiply it to, or map it to 3x minus 1. So if it's 4x minus 1, go to 3x minus 1. Do you understand what's happening here?
Yeah.
Do you want to do an example?
Sure.
Okay. Because this one has such strange behavior, I'm going to pick the starting point for this one. Because this one doesn't always go back. This one behaves pretty weird, surprisingly. I'm going to start with 4. Okay. What does 4 go to?
It looks like it goes to 2x. It's 2 times 2.
Okay.
So it goes to 6.
Right, so we find that this is 2x. So it's 2 times 2, so we must map it to 3 times 2. Okay. What does 6 go to?
6 is, it's the 2x.
Yeah.
Alright.
2 times 3 this time. So it's going to go to 3 times 3.
9. So now...
What about 9?
9...
Well, 9...
It looks like
it's going to go to 4x plus 1.
Yeah, because it's 2 times 4 is 8 plus 1 is 9.
Okay. So x is 2 now. Because this is 1 more than a multiple of 4. So we're here. It's 4 times 2, so it gets mapped to what?
Well, 3 times 2 plus 1 is 7.
Okay. Alright, where does 7 go to?
7 is... It's 4x minus 1. Because it's 2 times 4 minus 1.
Okay.
So it's going to be 3x minus 1 would be 5.
5. Very good.
And then you to the 4x plus 1.
Because 5 is 1 more than a multiple of 4.
Yeah. So x is 1 here. So we get to 4.
4 is the 2x property again.
But then we're
back there.
Hey.
So
Not arrow there, arrow here. So what's different about this particular one than what we see in the Collatz conjecture?
It's a loop. This one goes around forever.
This one's a loop.
now, maybe we could see if we see something like that in the Collatz conjecture.
Right. What would happen if we saw this in the Collatz conjecture?
Then that would be a number that would prove the Collatz conjecture didn't work.
I thought. Good job. Do you understand that?
Yeah, but no one's done that so far.
Sure, but why? So can you explain why this would prove the Collatz conjecture didn't work?
Well, because you've got the sequence of numbers, and then you have your starting number here. So it's going to be the same. It's the same pattern
All the way through, it just keeps looping.
Yeah.
So if this happened in the Collatz conjecture, we would have disproved the Collatz conjecture. It's pretty cool.
Yeah.
So I'm gonna do part C about this, but before I go to part C, how do I know I hit all the numbers here? How do I know every integer is either a multiple of 2, 1 more than a multiple of 4, or 1 less than a multiple of 4? Maybe there's some integer that I didn't hit.
Well, how do you know?
Yeah, how do you know?
Well, I see an integer. I don't think 0 works for all of them.
Okay.
Well, 0, it could be any of these.
Well, that's a good question. What would happen with 0?
0, it would be 2x because it would be 0 times 2.
2 times 0. So 0 would get mapped to what?
To 3 times 0 is 0.
Okay, so 0 works.
It would just repeat.
Yeah, 0 just actually repeats all. It's a loop of 1. But how can I figure out if how do I know there's not a missing number? Maybe 10 wouldn't work, or maybe 27 wouldn't work. It would just go nowhere.
Well, the 2x covers all even numbers.
Ah, okay.
That-
So let's look at a few. 0, 2, 4, 6. I know all my even numbers are good.
And the 4x plus 1 and 4x minus 1, those cover all odd numbers around a multiple of 4.
Okay.
And what about?
So
What about-
if we have a missing number, it's an odd number.
But
And it's not one away from a multiple of 4.
Okay. So why don't we investigate one of those two things? Which one do you want to
Let's
investigate?
look at 4x plus 1.
Okay. What numbers does that start filling in?
Well, 1,
1,
then 5,
5,
then 9,
9.
and then 4 times 3 plus 1 is 14. I mean, 4 times, it's 13.
And here was 12 back
So-
here. I skipped 10 and 12. Okay. What about 4x minus 1?
Well, that's going to do the opposite. But it would fill in minus 1.
Okay.
it would fill in.
Start with the positive ones.
Okay, so it's 3,
3,
That fills in these two.
and then it's going to be 7.
7.
So and then that would be 11. So it seems to fill in all of them.
Do you see what's happening?
Yeah, it's filling up all of the numbers
Okay, why?
because you're surrounding the multiples. Surrounding the multiples of 4 because the 4x plus 1 and the 4x minus 1.
Okay.
And then in the middle, the difference between the two even numbers, if one was a multiple of 4 and this one was a multiple of 2, the odd numbers between just the multiple of 2, there would be one odd number, 4x minus 1, and then the multiple of 4 below that, 4x plus 1. So we're covering the multiple of only 2.
Okay. All right. Good job. It's an interesting thing that we do hit all the numbers there.
Yeah.
All right, you ready for the next one?
Yeah.